So for today's Molecule Monday, you actually get a choice. You get to pick which one of these molecules that you would like to do today. Okay, so this is the chemistry of pumpkins as we're rolling into Halloween. You've got beta carotene that's responsible for the pumpkin's orange color. You have the aroma, which is the smell of pumpkins, either cis 3-hexen-1-ol or N-hexanol and 2-hexanal. The canned pumpkin, okay, so what compounds come from that? You have 2-methylbutanol, coffee furanone, and furofurol. That's fun to say. And then pumpkin spice, which is actually more fake than it is actually a real thing. You have the cinnamon aldehyde and the eugenol. So you're going to pick which one of these molecules that you want to do, and then write it down in your Molecule Monday. This is the first one for second quarter. Do not avoid the beta carotene just because it looks awkward. It's actually probably the easiest one to do. Really, it's just longer. So don't avoid it. That doesn't mean everybody go to this one. I'm just saying I didn't want you to avoid it because it looked longer, but it is probably the easiest one. After you have drawn out your structure, I want you to do your chemical formula and I want you to do your molar mass. Remember, the mass for carbon is 12, hydrogen is 1, and oxygen is 16, and that is all you need. So go ahead and pause your video, discover each one, and then when I come back, I will give you the formulas and the masses for each one. So for our beta carotene here, for the first one, our chemical formula is C40H56. C40H56. So I'm going to go ahead and pull up our calculator here. And we know that the mass on carbon is 12 and the mass on hydrogen is 1. And so we end up with a molar mass of 536 grams per mole for the beta carotene. 536 grams. So for our cis 3-hexen-1-ol, we have a chemical formula of C6H12O. C6H12O. So C6, you've got 6 times the 12. So C6 is going to be 72. H12, so plus 12, plus that O, 16, it's going to be 100 grams per mole. 100 grams per mole. All right, let's take a look at our N-hexanol. So 1, 2, 3, 4, 5, 6. So we're looking at C6. Now our H's, notice we don't have a double bond here. So for our H's, we'll have 14 because we don't have that double bond. So this top one, N-hexanol, is C6H14O. C6H14O. So we know 72 for the carbon, so 6 times 12, plus the 14 on the hydrogen, plus the 16 on the oxygen, and we get 102, which makes sense because there's only 2 more hydrogen. So that is 102 grams per mole. All right, and then our last one here, we have 2-hexenol, which means there's a couple double bonds on this one. So our chemical formula for this is still 6 carbon because it's hex. 1, 2, 3, 4, 5, 6. So C6, but these double bonds are going to throw us off. So our chemical formula for this one, C6H10O. The double bonds take off 2 of those hydrogens. So notice you can actually start taking shortcuts. If you know what the formula is going to be when it's single bonds, the double bonds are going to take off a certain amount of hydrogen, and you can start shortening that up. So our C6 we know is 72. H10 is going to be 10, plus that O, 16. Notice we're down now by 2, which is 98 grams per mole. Okay, so now we're going down here to our 2-methylbutanol. Our 2-methylbutanol. We've got C5, 1, 2, 3, 4, and 5, C5, H10, and O. C5, H10, and O. So that C5 times 12 plus the hydrogen plus our oxygen is going to give us 26 grams. That's not right. C5, that's going to be 60. Okay, try it again. H10 plus the oxygen is 16. Sorry. Okay, sorry. As my calculator went psycho about 4 times, I thought I was losing my mind. 86 grams per mole for the 2-methylbutanol. All right. All right, our next one for our coffee, if you're a known, own means there's a ketone, which is this double bond here. So for this guy, we've got 1, 2, 3, 4, 5 on your carbon, so C5. So that's going to give us our 60 again. All right, now for our hydrogen, we're going to have 8 hydrogen and 2 O's, so C5H8O2. So we've got that 60. C5H8, so there's the 8, and then 32 is going to be our mass, so 100. So 100 grams per mole on this one. Okay, our furanol. All right, so for this guy, we've got 1, 2, 3, 4, 5. So C5, so we're back to that 60 again. Okay, our H's on this one. This guy's good. This guy's actually good. This guy needs 1, so we've got 1, 2, and 3, 4. So plus 4. And then we've got the 2 oxygen, so 32. This one is 96 grams per mole. 96 grams per mole on our furol. All right, on to our cinnamon aldehyde. So our carbon, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So C9, 9 times 12. All right, plus our hydrogen. So now this is when we have to make sure that we're looking at who needs the hydrogen. So this guy right here needs 1. 1, 2, 3 needs 1. 1, 2, 3 needs 1. 1, 2, 3, 4, good. 1, 2, 3 need 1 here. 1, 2, 3 need 1 there. Okay, so this carbon has 1, 2, 3 needs 1. 1, 2, 3 needs 1. 1, 2, 3. We've already seen 1 coming off of there, and we're good. So on this, we've got 1, 2, 3, 4, 5, 6, 7, 8 of the hydrogen. So plus 8 hydrogen. So we're going to come over here back to this and add 8 hydrogen on. And then we've got 1 oxygen. So 132 grams per mole for our cinnamon aldehyde. All right, and then our very last possible molecule here, we had 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon, plus this one over here, so 10 actually technically. So 120 on the carbon. Let's check out our hydrogen situation then. So right here, this carbon has got 1, 2, so he's going to need 2 hydrogen off of the end. Okay, so then 1, 2, 3, need 1 here, need 2 here. This one, 1, 2, 3, 4 is good. 1, 2, 3, need 1. 1, 2, 3, need 1. This one's taken care of. 1, 2, 3, need 1. All right, so let's take up our hydrogen. We've got 2, 4, 5, 6, 7, 8, 9, plus the 3 is 12. So plus 12, and then our oxygen, we've got 1 and 2, so another 32. This one is 164 grams per mole. Those are your Molecule Mondays for Tuesday.